What's up, everybody? Welcome to a chemistry lecture about formula and molar mass. In this lecture, we're going to talk about what formula mass is, what molar mass is, and how to calculate them, because really, we calculate them almost in the exact same way. So let's get started. We know that a chemical formula is a combination of elemental symbols, all right, to represent a compound. And sometimes a compound can be made up of just one element, like our example here of chlorine gas. Chlorine is one of the 7 diatomic elements, one of the magnificent 7. All right, that's hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. All right, the magnificent 7 diatomics, which we'll talk about more later. Or a chemical formula can have many elements, all right, like HClO4, which has an H, a Cl, and 4 O's, or 1 hydrogen, a chlorine, and 4 oxygens. The numbers in the subscripts are the tiny little numbers, like that little 4 right there in HClO. They represent a ratio of one element to another, and if we have no number, it is assumed that the number 1 is there. All right, so in H2O, there are 2 H's and 1 O, because those are the subscripts. Here's the 2 for the 2 H's. That goes right there. There's actually a hidden little 1 right there. That becomes our 1 for the oxygen. All right. That's going to come in handy as we keep going on with these formula masses. Now, to find the formula mass, we need to do a couple things. And really, what formula mass is, if I was to define it, it is the mass of the chemical formula. All right, mass of the chemical formula is called formula mass. They busted the creativity box to come up with a name for this one. Anyway, to find this, we have to find the masses of each element, and we add them together. All right, so you got to remember your addition sig fig rules. We got to go least decimal places. All right, in order to do all this. Now we have to be able to identify how many of each element there are, and those are those subscripts that we just talked about on the last slide. And we use the mass numbers from the periodic table of elements. The mass numbers, they are the numbers, the mass numbers, they are the ones that have decimals. All right, and it actually depends on what periodic table you have, who made the periodic table, where the mass numbers are. A lot of times they're at the bottom of the box for the elements, but I've also seen them on the top left, I've seen them on the top right, I've seen them in the middle right, I've seen them in the middle. I've seen them all over the element boxes depending on the periodic table. So you really need to know your periodic table and where those mass numbers are. But it's always helpful to remember the mass numbers are the ones with the decimals. All right, and you multiply the mass number by the subscript. All right, remember the subscripts, again, the subscripts are how many atoms of each element there are. And then at the very end, we add the unit, because we know we don't want naked numbers. All numbers should have units here in science, and so the unit for formula mass is the AMU, which stands for atomic mass unit, AMU. And it's the units of atomic mass. An atomic mass unit is roughly equal to the average mass of a proton and neutron combined, which are very close. And as we'll find out later in the year, it is the AMU that helped us come up with everybody's favorite number that is called the mole, 6.022 times 10 to the 23rd, if we use 4 sig figs. 6.0215 times 10 to the 23rd if we're using 5 sig figs, or 6.02 times 10 to the 23rd if we're using 3 sig figs. But yeah, that mole number, that is how many atomic mass units are in a gram, and that will come up and play a role in a little bit. All right, guys, let's tackle some examples of formula mass. So we're going to start off kind of easy with a nice simple formula here. We're going to do what is formula mass of NaCl. That is sodium chloride, for those of you wondering. Sodium chloride has 1 sodium and 1 chlorine. So we're going to take a sodium, Na, and add to it a chlorine. When we add those together, we get sodium chloride. So sodium is in the first column of the periodic table, third one down, symbol Na, as you can see right there. Its atomic mass is 22.99 according to the periodic table I have, which, if you are in my class, is the same periodic table that you have. And chlorine is 35.45. Chlorine is element number 17. It's on the right-hand side of the periodic table. Third row down, second row from the end, 35.45. Now I bust out my handy-dandy calculating device. I get 22.99 plus 35.45. I get 58.44. That's to 2 decimals. Both my starting things had 2 decimals. So I am good with my decimals and my sig figs. I just pop the good old AMU unit on the end there. And there's my formula mass of sodium chloride. Like I said, that's a rather easy one. So we're gonna move on to a element that you might be familiar with from bio, at least if you took it at this school, and you had it last year. You saw C6H12O6. Most of you know this is glucose. All right, and glucose has 6 carbons, 6 C's, 12 H's, and 6 O's. And now we got to add all that together. So 6 C's is 6 times the mass of carbon. Carbon's number 6. Periodic table, second row down, 14th column across. It's 12.01. 6 times 12.01 is equal to 72.06. 12 H's is 12 times the mass of hydrogen, the atomic mass of hydrogen. Very first element, upper left corner, 1.008 is what we got there for the hydrogen. And that is 12.096. And 6 oxygens is 6 times element number 8 is oxygen. Its mass is 16.00, which is 96.00. All right, excuse me a second there while I zoom on in over here. There we go. And now what I'm going to do is I'm going to add those numbers up. 72.06 plus 12.096 plus 96.00. I get 180.156. However, if I look here, the oxygen and the carbon both have 2 decimal places, so I need to round to that second decimal place of the 5. The 6 is above 5. If it's 5 or more, raise the roof. And so we have 180.16 AMUs as our formula mass of glucose, which is C6H12O6. All right, let's move on. So now we're going to talk about something called molar mass. All right, and there's a little trick about molar mass. You see, earlier I said there's exactly 1 mole of atomic mass units in 1 gram. So if I change my units from AMU to grams of formula mass, if I do a formula mass but instead I put that in grams, it is called a molar mass. Molar mass is sometimes also known as gram formula mass, and it is also the mass of 1 mole of a substance. All right? So to find molar mass, we do the exact same thing, just instead of popping the AMU at the end there, we use the unit grams. And technically, you could use the unit grams per mole, because that is actually what we have. We have so many grams in 1 mole of the substance. That's what makes it a molar mass. As I said before, we could also call this a GFM, or gram formula mass. It's really up to you what you want to use. Why are there so many names representing the same thing? The short answer is the chemists of old hated kids taking chemistry, so they wanted to confuse you as much as possible. That might not be true, but, I'm going to just go with it, because why not? So let's do some fancy examples here of molar mass. And we're going to start off with a nice easy one again, just like we did for formula mass. Instead of using sodium chloride, we are going to bump each of those elements down a row on the periodic table, and we're going to go potassium bromide, or KBr. Potassium bromide. Now we have 1K plus 1 Br. Now a K is 1 space below sodium on the periodic table, number 19, 4th row down of the first column. It is, or has a mass of 39.10. And then the Br is right below chlorine, number 35, 4th row of the periodic table, in column number 17, second column from the right, and its mass is 79.90. So I take 39.10 plus 79.90. I get 119, but those go to 2 decimals, so I need the double zero. I got to keep my sig figs intact, and this would be in grams. All right. Or like I said, if you wrote grams per mole, I would also mark it right, because they are essentially, we're talking about the same thing here. All right. I would take either. When we start getting into more complex unit conversions later in the year, then you'll see where that grams per mole can be used in a factor label method question. But that is for another day and another time. I'm going to move on now to this bottom question, which is what is the formula mass of C2H5OH? All right, I'm doing this one because it's a little bit sneaky. All right, we have this extra H right over here, so we need to remember to add it to that one. It's written like this because it's an organic compound. It has what is known as an alcohol group on the end, and this is ethanol, which is a type of alcohol and the type of alcohol that it is in most alcoholic beverages. All right. That does not mean you can go into a chem laboratory, find the ethanol, and drink it. They use a denatured ethanol in the laboratory, which will cause you to get violently ill. And therefore, it's not good for you. Not that the other stuff is good for you, but the denatured stuff is intended to make you sick, because it actually could cost less per unit volume. But we're not going to get into that. That seems like a question of some type of unit conversion later on down the line. What is more, drinking alcohol or chemical alcohol that's denatured. We're not going to get into that. We're going to just find the formula mass. Oh, I don't want the formula mass. This is me doing the wrong thing here. We're going to go in. We're not going to find a formula mass. We're going to cross out that word formula. And we're going to replace it with the word molar. And we are going to find a molar mass of C2H5OH. And now that I'm thinking about it, I needed to kind of do that up at the top here too. That's a change, and it's going to be forever, because now this is on the worldwide inter-Google Bings, and I can be picked on for it. But that's okay. I can handle it. It happens. We make mistakes, and we move on. So, we're going to find the molar mass of ethanol, C2H5OH. C2H5OH has two C's, 6 total H's, because don't forget that one from the other side of the O, and 1 oxygen. So I take 2 times the mass of carbon. Mass of carbon is 12.01 times 2 is 24.02. 6 times the mass of hydrogen, which is 1.008, which gives me 6.048. And the mass of oxygen is 16.00. There's only one of them, so I'm just going to move that 16.00 over. Grab my handy-dandy calculandy. 24.02 plus 6.048 plus 16. I get 46.068. But once again, the little siggy figgies are being sneaky. I need to go to that second decimal, which is the 6. The 8 tells me to round the 6 up. So I get 46.07 grams, or grams per mole. I'm not going to repeat myself on that right there. And so what we end up with is the molar mass of ethanol. And that's it. That is this lecture. That is this topic tonight. For the rest of this period, if you are watching this in class of mine, I have a couple of worksheets that you're going to be getting, and you are going to be practicing finding molar masses and formula masses on those worksheets. We'll talk about them next class. Hope you enjoyed this, and keep on keeping on.